Okay, can you hear me? Hello. Just we're waiting 1 minute, then we start our today's session. Hello, good evening. Can you hear me?
Good
Hello.
evening. Yes.
Okay, just we're waiting 1 minute, then we'll start.
Uh,
Okay. Yeah, welcome. Okay, so we will start out today's session. So basically, today is our third number test, and I hope all of you already get the previous recorded class and also get the previous material, mainly practice code or others material you can easily get from our Google Classroom. Yeah. So basically, today's session I discuss about that water resource management. Okay, how we can easily use the Google Earth engine and how we can easily monitor the water resources. Okay, in remote sensing, as well as also talk about the other topics also. Okay, so after completing the live session, then we talk about the problem solving class. Okay, after completing the 3 hours live training program. Okay, so let me share my screen. Is it visible?
yes.
Okay, thank you. So let's go. That how to calculating any indices from satellite images. Okay, so basically in remote sensing we are using different types of indices or index. So this type of index, how we can easily compute using Landsat or Sentinel-2 satellite imagery. We also discuss about that, as well as how we can easily struct the water, how we can easily identify flood mapping, how we can easily identify water logging area. So this type of things I also discuss in here, as well as we also discuss about that how to apply thresholding technique and extract the water body. Okay, and how to make the time series chart for different types of indices, as well as how to export any shapefile from Google Earth Engine, and how to add the legend and also flood mapping using SAR data. Okay, and also discuss about the monthly time series chart, how we can easily create. Okay, this type of things. So let's go and try to explain all of those from beginners to advanced level, so then I thought that you can also apply for your research work. So let's go. So first of all, water resource management. So basically how I can detect the water. Okay, so let's go how to detect. Okay, let me refresh it. Some network, just a minute. Okay, so first, how to detect water body from satellite imagery. Okay, so we can easily detect the water body using satellite imagery, different types of satellite imagery. If you want, you can use it at the Landsat. If you want, you can also use it at the Sentinel. If you want, you can also use it at the Sentinel-2 or Sentinel-1. Okay, as well as we can also detect the water body using MODIS. Okay, so yes, we can use and identify water body. It can be Landsat, it can be Sentinel-2, it can be Sentinel-1, or it can be MODIS. Okay, any satellite image we can use, and further we can easily detect the water body. But which one is more better? Landsat, Sentinel-2, Sentinel-1, or MODIS? So which one is more better? So in this case, it's depend on your project work. Suppose you want to monitor historical data analysis. Okay, so then you try to use the Landsat image for historical data analysis. Suppose you want to identify for historical flood analysis from 1990. Okay, so you want to identify historical flood data analysis from 1990. So very past time you want to identify for flood. Then you try to use here the Landsat. Okay. Then for the Sentinel-2 satellite imagery. So basically, suppose you want to identify not mass present, but suppose year of 2020 or 23. So this type of time, it basically the Sentinel-2, it's better resolution. Okay, it's provide the better resolution than Landsat. Landsat, but it's available from 2017 or 2015, not very first time. Okay, but Sentinel-1 is very important to identify for flood, because this image is not affected, it's not affected by cloud. Okay, suppose you want to identify present condition of flood, present time of condition of flood, then we try to use here the Sentinel-1 satellite imagery, because it's not affected by cloud. Okay, so that's why it's very important. Suppose now present time you want to for update time or near real time you want to identify for flood, then you try to use the Sentinel-1 satellite imagery, because it's not affected by clouds or haze. So then we can easily identify Sentinel-1 satellite data, and we can easily identify for water body, and we can easily identify for flood inundation mapping. So I will try to explain all of satellite imagery. And MODIS, basically MODIS, it's one kind of ready-made product. We can also use here the different types of MODIS ready-made product. So it's not the good resolution, but it also provide you with a good map for the big study area. So for the big study area, it's provided good map. Okay, for the big whole study area, suppose whole country boundary of Bangladesh or whole country boundary of India or any big study area, it provides the good map. But for a small study area, it's not good work, because this resolution is not good. So this type of satellite image, how I can use, suppose Landsat, Sentinel-2 and Sentinel-1 and MODIS, how we can easily use and also detect the water body. So I also try to explain all of those step by step, then I hope you can easily get the idea. So first of all, we discuss about the Sentinel-2. Okay, then talk about the Sentinel-1, then talk about the Landsat, and finally MODIS, how we can easily detect the water body and create the flood map or water logging map. So this type of things, how I can create, I'll also explain all of those step by step. So let's go. So first of all, we discuss about the Sentinel-2 satellite imagery. So Sentinel-2 satellite imagery for water, suppose water logging map. I want to identify Sentinel-2 imagery for water logging map. So how I can do it? So it's very easy. First of all, if you simply go to the browse data catalog and then open your data set for Sentinel-2. Click on the Sentinel. And I want to use Sentinel-1 and Sentinel-2, both of satellite imagery. So first I try to show you this Sentinel-2. Okay, so just if you check the Sentinel-2, basically we find out the surface reflectance and top of atmosphere reflectance. So I want to use the surface reflectance because it's the atmospherically corrected imagery and it's provide the more better mapping when you're using the signal surface reflectance. Use it. Click on here. So if you check, we find out all of information. This data set is available from this time. Okay, and this data set is provided by European Union, yes, Copernicus, and this is the snippet ID about this data set. And if you check all of data set band name, aerosols, blue, green, red, then red is 1, red is 2, red is 3, near infrared, as well as if you check this type of data have a scale value, okay, 0.001, it's a scale value. So we need to use this type of scale value to get the more better reflectance value. So further I will show you that how we can easily use this type of scale. So this data set I want to import in my code editor. Just I simply copy and then import this data set. Okay, then give a variable name. We already know about that how we can easily detect the variable name. So put a variable name. Before the name, just put the var keyword and put the name. I put the name, suppose S2. You can put any name as a variable. So now this is my image collection. Okay, this image collection I just simply store it in this variable. So now we already discussed a lot of time for filtering, how I can easily filter my satellite imagery. So now I simply import my study area. So here I already imported my shapefile, and I already discussed about that how we can easily import our boundary shapefile. So let me import my study area, which area I want to work. Suppose I want to work for this Dhaka city, imported in my code editor. Okay, it's imported. Then further give a variable name. I put the name, suppose ROI. You can put any name as a variable. So now I simply filtering my study area for this Sentinel-2 satellite imagery. So first of all, I simply use here the filter bounds function. Filter bounds with my study area is ROI, and then I use here filter, suppose filter date function. Suppose I take the imagery year of 2020, or I take the suppose year of 2024, 1st January. I take the 1 year data and also put year of 2024, suppose December 31. Okay, so just I take my whole year. So now if I check how many images, and I also just simply filtering the image metadata. So put here the filter metadata to filtering image properties. Suppose in this case, if you check the image properties tab, here we find out that cloud pixel percentage. Just I use it as the image properties name and then paste here. And then I simply put here operator less than and set the value 1. Okay. So now I simply filtering my image collection, and if I just print, suppose just I print and check the S2, how many images are available in my collection, I want to check it. So for that I simply run the code. It's computed how many images are available for my study area. So here I find out total 25 images. Okay, this is my total 25 images are available for my study area, less than 1% cloud covered. Okay, and it's available in my region of interest, and it's available between this time period. Okay, and it's less than 1% cloud cover imagery. I find out 25. So this image collection I need to multiply with their scale value. If you check, it have a scale value. You can see all of bands have a same scale, 0.01. So this is a scale value. So this scale value I need to multiply, because I just simply make the better reflectance value. Okay, make the better reflectance value. So for that I simply basically to get the better pixel value. So that's why I need to multiply this value with that. Just if you check, I simply put here that multiply function and then multiply with this value, and if I run, you can see it show a problem. Okay, this is a problem. So it show the problem look like that. You can see e.image collection filter date filter metadata dot multiply is not a function. Okay, so it's not a function. So in this case, this multiply function is only work for image. Okay, so but it's a image collection. Okay, so I also write the comment s2, this variable is a image collection. Okay, image collection, it's a image collection. Image collection here, total how many images we find out? 25 images in this s2. This variable is stored 25 image collection. So now this is the image, it's a image, so it's a image collection, but when I multiply function is only work for image. Okay, so I also write the comment, so multiply, this function is only work for image. Okay, not image collection. So now if you simply check how I can say multiply is work only for the image, so you can simply search on the docs tab and find out the image section. You can see image is one kind of data type of Earth Engine. So if I just click, and you can easily find out the multiply function. If you check, we find out a function, it's called the multiply. Yeah, we can see the multiply. Okay, so multiply function is available in our image data type. You can see it's available in the image data type. So that's why this function is only work for image data type. Okay, image data type. So I'll write it is only work for the image data type. So now I want to use this multiply function and connecting with my collection. So it's my collection. So this collection I want to multiply with this value. So now I just, for that, suppose image collection multiply 0.0001. So I have an image collection. This image collection basically I have total 25 images. Okay, these 25 images I simply multiply 0.001 all images. Okay, all images I just simply multiply. So now how I can do it? So for that we need to create a function. We need to create a map function. So if you simply search here what is the map function, just click on here map, and if you check you can see the map function. Yeah, so you can see the map. It's not just a minute. Yeah, so maps one algorithm over a collection, you can see. So map is one kind of function. So maps an algorithm over a collection. Suppose I have a collection, so now I create a function, I create a algorithm. So this algorithm I simply connect with my collection, so then I need to use the map function. So let's go try to create a map function and connecting and multiply. So for that we just create a function, suppose. And how we can easily create a function, suppose I just take a variable name, I put the function variable name, suppose scaled images. So then put the function and put the keyword, suppose image, and put the curly bracket. In this curly bracket I just put my argument. So what is my argument? My argument is that this return this image multiply with this value 0.0001. Okay, this is my argument. So now I just copy these properties. So copy properties of this element and apply system time star to system time int. Okay, so I create a function. So this function I need to connect with my collection. This is my collection. So how I can connect? For connecting we are just use here the map function. So just I copy the function collection s2, it is stored total 25 images, I simply paste here, and for connecting just use here the map function, just put the map function. Okay, so now this is my variable scaled image. So if I just print and then check how many, just I copy and use at the size function and run the code. Okay, so okay, we also need to remove this code, multiply. Okay, just run the code now. So now I can see it also computed 25 images. So now what is the difference, this 25 and this 25? First image collection is not multiply with this value, but second image collection 25, it's multiply with this value 0.001. So now this is my image collection. This image collection is multiply with this value 0.001. Okay, so anyone any question for the concept, you can ask me, or any confusion you can ask me. Can you get the
Yes,
idea?
like
Yeah.
what changed, for example?
Yeah.
Why did the multiplication change? Because it remains 25.
Yes. So in this case, we find out the same number of image collection, but now this image collection, 25 image collection, is multiplied with 0001. So all of images multiply 0.001. Our scale value is multiply all of images which are available between this time period. Basically 25 images. We have total 25 images. All of images is multiplied with this value 0.001. Okay, so this image collection is stored 25 images, and all of images, each images is multiply 0.001. Okay, and you can see, suppose in this case, I will already show you that. So in this case, if I just use the multiply function in here and app multiply 0.001, then it show a problem. This problem is that this function is only work for image data type. Okay, image data type, but this s2 is not an image data type, it's an image collection. Here total 25 images, but I need to multiply this value anyhow. I need to multiply. So how I can get this multiply? So for that, we simply create a function, this type of function, and multiply with the 0.001. Okay, multiply 0.001. So now 25 images is multiply with this value 0.001, and we find out the better reflectance value. So this value, why I just multiply? Because when I multiply this value, all of images, it provide you the better reflectance value. We find out. Okay, so that's the region. We simply multiply our scale value. This is the scale value, you can see 0.01. So previous class we discussed about the MODIS NDVI or MODIS LST. So this type of data set we also multiply the scale value. Same process we simply apply in here. Multiply 0.001. Okay. So now we find out the total 25 image collection, if you check. But I want to filter this image collection seasonally. Suppose I want to filter this 25 in dry season and suppose rainy season. Okay, so this 25 images just simply filter suppose dry season and rainy season. Okay, so two season I simply separate or filter, so then I can easily compare for the dry season water body and rainy season water body. Further we try to calculate how much water body increase in the rainy season. Okay, so let's go try to filter these things. This 25 image I simply filter for the dry season and rainy season. So for that I just take a variable. Suppose I put the variable name is dry images. Okay, so now I call the scaled images. It is stored 25 images. So now this 25 image I simply filter dry season and rainy season. So just paste here and then apply a function, filter date function. So I simply put my dry season time period, suppose year of 2024 1st January from year of 2024, suppose May 30. Okay, so this is my dry season time period. So now if I just print and check how many images are available in the dry season. Use the size function. So now it's computing how many images are available in the dry season. So we find out that 25 images, okay, are available in the dry season. So I think in the, okay, sorry, it's a 24. So now let's check 15 images. Okay, we find out that total 15 images are available in this time period, or dry season time period, which I put in here, January to May. Okay, so now let's check how many images are available in the rainy season. Suppose rainy season, I take a variable rainy season and call the scaled images because it stored all of images, and further I filter. So filter date and apply, suppose year of 2024. I put the time, suppose 0601. Okay, then put here year of 2024. Suppose I put the October 31. Okay, so this is my rainy season time period for Bangladesh. So just I put this time, and now if I check how many images are available, if you check rainy season, just I copy and check how many images are available. So just run the code. Okay, in this case, if you check, we find out the total 0 image. Okay, so it shows the 0 image. So between this time period, there is no image which is less than 1% cloud cover, because in the rainy season, all time we find out the lot of cloud on the sky. So that's the region there is no image. There is no image between this time period. Okay, so there is no image between this time period. We find out there is no image. Less than 1% cloud cover image is not available between this time period. So now how I can get the solution? So for that, you can simply increase the time period. So increase the cloud level. So now let me check for the cloud 5%, what happened? Less than 5%, run the code. Also it showed that there is no image, less than 5% cloud cover. So let me check for less than 10%, what happened? Just run the code. Okay, we find out the 2 images. Okay, in the rainy season we find out the 2 images. Okay, so now we find out the images. Okay, between this time period we find out the 2 images are available, and between this time period we find out the 20 images available, and both are the 10% cloud cover, less than 10% cloud cover we find out. So now I want to use both of images. Suppose I want to use this image and also use the image and create the mosaic and create the composite. So previous class I discussed about that we can create the different types of composite. It can be median is one kind of composite. Okay, so you can see the median. So median, you can see median basically calculate the median of all values at each pixel. Okay, but when I apply the mosaic, if you simply search here mosaic, so mosaic composite all the images in a collection using max without calculating any kinds of statistical value. Okay, it's not calculate the median, minimum, maximum, anything, not compute any kind of statistical things, just composite all the images. Suppose I have 20 images, so this 20 images in a collection using max and create the composite. So let's go and try to apply the mosaic. Just I copy the mosaic and then just put here this function mosaic, and then clip with our study area, which is ROI. Okay, and same process also apply in here for the rainy season. So put here the mosaic and clip with our study area, which is ROI. So now we try to display our imagery. So let's go try to display. So just take a very map.add layer and connecting with our dry images. Just I copy and paste here, and also add another layer for the rainy season images. Okay, so just same process, map.add layer, and I want to add the layer for rainy season images. Just copy and paste here and run the code. So now, okay, so now if you check, this is another good question. Here you can see you face a problem. Size, it show the size is not a function. Okay, because in this case, when I apply the mosaic, this variable is not a collection, it's just a mosaic image, single mosaic image. So that's the reason we find out this type of problem, because size, this function size is only work for image collection data type. Okay, so size function is only work for the image collection data type, but when I apply the mosaic, so it's not a image collection, it's just a mosaic composite image. Okay, so that's the reason we find out this type of problem. So now I simply comment this line and also comment this line, because when I apply the mosaic function, so now this variable is not a collection, it's just a single composite image. So that's the region it show this type of problem. So let's go try to run the code and check. So now you can see it's added the layer but not focus my given study area. So let's go try to focus on our given study area. So just map dot center object is ROI. I want to focus, zoom level 10 and run the code. So now if I run the code, we find out this type of images without visualization. Okay, so let's go try to add the visualization. Mainly band combination we try to add. So let's go, just click on the suppose second layer, just click on here, and I want to add suppose I want to add this band combination, near infrared, or you can use any band combination. I put the near infrared, then red and blue. Okay, just stressing level I put, and then further apply. So you find out this type of image collection image. Okay, so these things I simply import, you can say I simply import. Okay, and further I want to add this image, I want to add the band combination. So I put the same, suppose I put at that near infrared, then red and blue, stressing 98%. Okay, and now apply, just apply. So we find out this type of image collection. So now import. Okay, so further just simply copy. Okay, this one is for that. I simply put here in the dry visualization, and I put the layer name, it's a dry image or dry season image, and I put the another one. So this one just I copy, and I also put here, just paste here and put the layer name, it's a rainy season image. So now run the code. So now we find out our satellite imagery. So if you check, we find out the two satellite imagery for the two season for our given study area, rainy season, and also find out the imagery for dry season. Okay, so if you check, we find out this type of imagery. Okay, and basically this type of black color or dark color indicating about the water body. So if you check, this is the rainy season, this is the dry season, you can see. Okay, this is the dry season imagery, and if you check, this is the rainy season imagery. Okay, in the rainy season you find out that water pixel is increased. If you can check, we find out that water pixel is increased. Okay, so you can see this type of place, there is no water in the dry season, but when I open the rainy season, we find out the lot of water body. Also you can see this type of place, there is no water body, but we find out the rainy season, it's a water body. So if you check, you can see there is no water body. Okay, but when I open the rainy season image, we find out the lot of water body. Okay, so we find out the two satellite imagery for the two different time. So now we try to detect the water body. Suppose from this dry image, I I detect this type of water body, and also from the rainy season image I detect the water body. So how I can detect the water body, in this time we discuss about that. So let's go. So now we can use different types of water index. If you want, you can simply search here, suppose water index in remote sensing. Just open it. So in the remote sensing, we are using the different types of water index, and also have different types of application if you check. So you can see water indices as a monitoring tool. So we are using the different types of water index. So you can see it's a one kind of water index. It's called the NDWI. NDWI basically normalized difference water index. Okay, normalized difference water index. And if you check, this is the formula about that NDWI. Near infrared minus short wave infrared 2 divided by near infrared plus short wave infrared 2. So it's one kind of formula. Okay, so we are just use the formula to compute NDWI. Okay, and we can use the different types of uses for NDWI. So it's one kind of water indices. If you check, this is the another one. It's called the WRI, water ratio index. Water ratio index, and this is the formula WRI. So we are use it to identify water, as well as if you check, this is the another one. It's called the MNDWI. Okay, MNDWI. So this is the formula about the MNDWI. Okay, so we are using here the different types of formula to identify water in the from the satellite imagery. Okay, so let's go. I try to apply a water index. Suppose I want to apply this one NDWI, and this is the formula. This is the formula. Calculate formula NDWI. So now how I can use this formula, and then how I can detect the water body from these two satellite imagery, dry season and also rainy season. Okay, this is my formula. Suppose I want to use it. You can use any formula. So I want to use the formula and detect the water body. So this formula is that if you check, near infrared band minus short wave infrared 2 band divided by near infrared plus short wave infrared 2 band. So now if you check near infrared band, so this is the near infrared band, okay, B8. Okay, this is the near infrared band. And if you check short wave infrared 2 band, it's a B12. So I need to use B8 and B12 to compute NDWI. Okay, so let's go and try to compute the NDWI using our satellite imagery, dry image and rainy season image. So for that, I put here, I compute suppose NDWI dry season. I want to compute dry season. So take a variable. I put the variable name okay. So I put a variable name, suppose NDWI dry, and then just call the dry season image. Basically, I want to work with the imagery, so simply call the dry season image. So here is the dry season image. You can see this is the dry image. Just I copy this variable and apply, just paste here. So now I want to compute this equation, okay, in this image. So just I use the image and compute this equation. So we can use a function. It's called the normalized difference. So it's one kind of function, normalized difference function. So if you want, you can simply search here normalized difference, this function. Okay, so you can see compute this normalized difference between two band. Okay, Suppose in this equation we have only two band, near infrared band and short wave infrared two band. So I want to compute the normalized difference in two bands, and if the bands to use are not specified, use the first band. Suppose first band is the near infrared, second band is the short wave infrared two band. So just I simply use this two band and apply this normalized difference function and mention the band names. Band names I simply put in here in the bracket. So let's we try to put the band name. So first band is the B8, second band is that, if you check, band name is for B12. Okay, B12. So just I write here B12. So now this is my dry image. So this dry image I just simply compute normalized difference near infrared band and short wave infrared 2 band. Okay. So now I just copy the same line of code and apply for rainy season. Rainy. So now call the rainy season image. Just I copy and paste it. So now we computed the dry season NDWI and also rainy season NDWI. So I want to visualize these two map. So just map dot add layer, and I want to add the NDWI dry, and also add the layer map dot add layer, and I want to add the layer for rainy. So now run the code. So now it's display the result 2 layer for NDWI in the rainy season and also dry season. So we find out this type of map. If you check, so it shows the gray color. Further we try to add the color. So this, so we find out this 2 layer. If you check, we find this 2 layer. So let's try to add the color. So how I can add the color on this map? So for that, just click on the setting button and just I put the stressing level 98% I keep, and then I add the plated, color plated. Basically negative pixel, it's not the water body. So I want to use this type of color for that. And also I put here suppose this type of color. Then I put suppose this type of color. And for the water I put this type of color. Okay, this type of color, and now apply. So now this color is set in our map and we find out this type of map. Okay, so after that I just copy this color from here and also import. Okay, so here, when you can say, I just click on the import, just import the color code. Okay, just import, and now I want to apply this for this imagery. So same process, just click on here and I just keep the stressing 98% I keep, and I want to apply the color plated. So just I paste the color, same color I just keep, and then apply and also import. So now if you check, so if you check, we find out the some difference. If you check this map, this is the dry and this is the rainy. Okay, so we find out that in rainy season it increase the water body. So let's we try to set the visualization parameter in our map.
Sorry, where do you press when you are putting the colors?
Okay, so from the setting button you can see the setting button. Yeah, just click on here and you can click on the plated. Okay, then different types of color you can simply set. Okay, suppose just simply set the different color and then apply, and further this color you can easily import. So for importing, just import, then you can see a new line of code will be added in here. So further copy this variable name and paste after the object name. So just I paste here Suppose I put the layer name. In this time it show that you can see layer 3 and 4. I add the layer name. Suppose it's a rainy season, and copy this another visualization of color and paste this layer and add the layer name. Suppose it's a dry season. So now run the code. So now this color is set it with our map. So basically this type of blue color indicating about that water pixel. Yes, we can use this type of things. Also, this is the one way to monitor the NWI. Suppose I want to apply the another formula. Suppose you can see that a lot of formula is available for the water index. So you can also apply this formula and then check the result. So you also try this formula. Okay, then we can easily get this WRI. Basically, it's a water ratio index. Suppose I want to apply this one. Suppose MNDWI, this one. Okay, you can also apply this formula. So it's a green. Okay, suppose I want to apply it and then check the difference between the two equation. Suppose I want to apply this formula. So in this time, green band, green and short wave anyway 2 band. So just I simply change it, green band. So if you check what is the green band is the B3. Okay, so just apply here the B3. Just put here the B3 and also apply here the B3. So now run the code. So now you can just use the equation. Okay, so now when I put the normalized difference function and put the band name, it's automatically computed B3 minus B12 divided by B3 plus B12. Mainly this equation is computed, okay, automatically. So now run the code and then check the result. So now this result come from this equation. So we find out this type of map, but I want to add it more interactive, looks more better. So for that we simply increase the stressing level. Suppose I just click on the rainy season, and if I just stressing level again 98%. So now just apply. So now this visualization is more perfect. Okay, we find out this type of map. Okay, when I apply the 98%. So further, if you want, you can simply import. Okay, and then suppose I want to apply this thing in here. Stressing level 98% I keep and apply and also import. So now if you check, we find out this type of map. So this is the map for dry season. Okay, dry season, it's not much water body. If you check, this type of place have the water body in the dry season. But when I open the rainy season, you can check what happened. We find out the lot of water body, this type of water body, this type of water body, we can also find out. Okay, so now I want to identify. You can see this is the water, this is the difference between the two layer. This is the dry season condition, not much water body. But when I open the rainy season, you find out the water body is increased. Okay, so now from these two images, rainy season and dry season, I want to separate the water body. I just keep only for the water body. Others I don't need. I need only for the water body from these images. So how I can do it? So for that, first of all, you can simply print, simply just make a histogram. So for that put here print. Suppose I print UI dot image dot histogram. Okay, just I create a histogram for these two images. and then call the NWI dry. Just I copy and paste here, and then put here the ROI scale 10 meter. Okay, same process also do for just I print the another histogram for this NWI. Okay, just run the code. Okay, it's a problem. UI.image is not a histogram of undefined. Oh, sorry, UI.chart. Chart. Okay, so UI.chart. So now run the code. Simply search here, then you can get the function UI.chart.histogram image dot this one. So you can see this is a function. Okay, so this function generate a chart from image. Okay, compute and plot the histogram of the values of the bands in a specific region of the image. So now I create this type of chart. If you check, we find out this type of histogram chart. So this one, just I click. So this one is for dry season. Okay, this is the histogram for dry season. Basically, it show the pixel value, NWI pixel value we find out in here. Okay, and if you check, just click on here. So this one is for rainy season. Okay, in the can see there are a lot of, we can get the high value. We can see 0.8 pixel value. So basically high positive value indicating about the high water, okay, density. And if you check, suppose this one is not mass, this one is show only for 0.4 or 0.3, okay, not mass, 0.4, okay, but this one is the highest pixel. We find out that 0.8 or 0.9 because it's a rainy season. We find out the high water NWI pixel value, but in the summer season or dry season it's not much high. Okay, so let's go try to identify for water body. Basically this type of negative pixel, it's not the water. This type of negative, you can see this type of negative pixel, it's not the water, it's the other feature, not water. Water mainly for positive NWI pixel value. Water is the positive. So if you check, let me find out that threshold value. If you check, this is a 0. So after the 0 we find out the 0.008. Okay, so this value I want to use, and I put the greater than 0.008 all of pixel. Suppose greater than 0.008 all of pixel I consider as a water body for dry season image. Okay, 0.008. So let's go, I try to apply for that for dry NWI greater than 0.00. Okay, let me check again. .008. So just I put here 0.008. So just I use it. So take a variable, suppose water in dry. Okay, and further I just call the NWI dry, and I keep greater than 0.008. So let's go try to add the layer. So just map.add layer and call the water dry, and I create the binary class, suppose 0 and 1 binary class I create, and where there is no water it show as a gray color, and where is the water it show as a suppose blue color. Just I put the two class I create. Where there is no water it show as a gray color, and where is the water it show the blue color. So now run the code, we find out this type of another layer. Okay, so now this layer display the water body in the dry season. You can see find out this type of water body. So this is the water body map. In the dry season, we find out this type of water body map. Okay, this type of place we find out the water in the dry season. You can also add the, suppose you can also add the layer name. Suppose it's a water body in dry. See. Okay. So now we apply the same process. Just simply check the value from here. If you check, we find out that 0 0.01, 0 0.06, 0 0.03, 0 0.08, then 0. I think it also same. We find out that 0 0.01. Okay, negative is not the water pixel, so only positive. So if I find out same, you can say 0 0.08. So I keep the same. So now I want to apply. Suppose just call the, take a variable. Suppose water in rainy season. So just call the NWI rainy season, and I keep the pixel greater than 0 0.008. Okay, so now just add the layer. So just I copy the same line of code and paste here and change the object name. Okay, I put it's a rainy. So now run the code. So now we find out the water body in the rainy season, only for the rainy season. So now if you check the map, then you can get the difference between the water body in the rainy season and summer season. So this is the result for rainy season. We find out the lot of water body pixel, you can see. And this is the result for dry season. Okay, so this is the dry season condition of water body, and this is the rainy season condition. Okay. Rainy season, it increase lot of water pixel, you can see. So you can see this type of place, there was no water in the dry season, but rainy season we find out the water body, you can see. Also this type of place, it increase lot of plus, you can see. Okay, so anyone any question about it, you can ask me, or any question you can ask me for that. Detect the water body for the seasonal water, how we can easily extract. Any question about it, you can ask me, or you can got the idea how it will be work. You can also confirm me.
This is the surface water, right?
It's a surface water, yeah, surface water.
Is there a way to detect it underground, for example?
Groundwater, it also possible, but further we need to apply the some other factor we need to include, and then we can also identify for the groundwater. But it also possible, we can also identify groundwater potential zone using identify different types of factor. So it also possible using remote sensing to identify groundwater under the ground surface. Okay, but it's the surface, not underground. Okay, just only for the surface water condition we can apply this type of things, and you can easily detect the surface water. And you can see it also increasing lot of water. So now I want to calculate, suppose how much water in the rainy season, mainly change detection or difference. I want to compute difference, how I can compute the difference, how many water area we can got in the rainy season, we try to identify. Okay, so it's called the difference or change detection between the two layers. Then we can easily identify how much area, we can easily calculate the area, how much water body area in the rainy season, we can easily calculate the area. Okay, so this is the one process to identify for water body. So I also discuss about that sentinel to satellite imagery and we discuss the water body. Same process you can also apply for the Landsat. Landsat basically 30-meter resolution. Sentinel-2 is the 10-meter resolution. But when you work with historical data analysis, suppose historical flood data or historical water logging data, then you try to apply the Landsat because it's available from, you can get the data for the Landsat available from 1975 or 73 or 75. We can get Landsat 5, this type of data. So also Sentinel-2. And now we talk about the Sentinel-1. Okay, then we talk about the change detection. Okay, so how I can detect the water, using Sentinel-1 satellite data. Okay, because Sentinel-1 data is not affected by cloud, it's not affected by any kinds of others atmospheric condition, so we can easily get the better imagery in the flood condition. Suppose you want to easily compute update condition of the flood using the Sentinel-1 data. So let's try to discuss about that, how to detect water using Sentinel-1 data.
Can we get a break?
Okay, just we make a break for 5 minutes, then we start again. Okay, then. Okay. Okay, welcome back. Can you hear me? Hello. Okay, so now we talk about that how we can easily use the Sentinel-1 serve image collection, and further how we can easily monitor the water. So let's go. So let me open a new code editor.